We're working on developing a kit that would help farmers that are out in the field to estimate the amount of microbes and bacteria they can find in a certain amount of compost extract or compost tea. It's far more practical for a farmer to use compost tea as opposed to using the actual compost. Most of the nutrients can be extracted through the extract or through the tea, and first of all it makes it more practical because the same amount of nutrients that you would find in 10 or 20,000 pounds of compost you would have in 100 gallons of compost extract or compost tea. So it's a huge difference. Most people think that when we use a compost, there's nutrients or minerals that can be found there that are helpful for optimal plant growth. That's not exactly true. The main thing that helps plant growth is the microbiota in the compost.
This is how I start the experiment. So this is our compost, which we brought from the rocket from outside. So we use some amount of compost and other type of stuff that I'm using for. So this is we use tap water, and our tea compost is inside it. We put inside the sack because we want to make sure that it stays separate from the water. And from there, after this tea compost needs to stay 24 hours. So after 24 hours, I pour some of them in little beaker and then use for my experiment. After my I finish my cereal dilution and I start plating. And here I'm doing two different type of plating. As you see, those are different type of bacteria, really nice bacteria that I grow up in the place after 24 hours.
So we've talked about how to make the extract, we've talked about how to do the dilution and the plating. So now what we need, how many bacteria, the question is how many bacteria are in our sample, whichever sample we take. And that's where we come in right over here. We take the extract, we put it in these little test tubes here, but we can't really see anything from this because the humus is too dark. The humus is too dark, so because of that, anything we're going to try and do to read this humus, we're going to get a false reading. So what we need to do is we need to titrate this to make sure that all we're getting is how much bacteria is in there, not how much humus is in there. So, just going to show you a quick titration right here. So, titration to get the best results, you usually have to wait about 5 minutes. No, but since I've been watching those cooking shows, I know that you already have to have something ready made. So, there we are right here. You see that? So now, what you have to do, oh, there's the sample. You see it? There we go. Anyway, we're starting the spectral photometer off at an absorbance of 0. So, because we know that there's bacteria in here, we know that this is going to affect what the spectral photometer reads. So I'm just gonna put that in there. Shoots up. So now this is an accurate reading. This will give you an accurate reading of exactly how much bacteria is in here. So after we have gotten the readings, after Fakir has done the plating and after we have titrated it, what we're going to do is we're going to record those readings, and then we're going to correlate them. We're going to put them together to see if they correlate. Then we graph that. So far we're getting very good results. We're getting a good correlation between the number of bacteria we see on the plates and the absorbance we're getting from the test tubes.